lesson, I encourage all of you to put down a pen and really try and see what you can learn from this. I'm using a different approach now. The function f is defined, okay, for all values of x. Do you understand this statement? You have to understand, right? So they tell us, oh, it's a function. You input something, it outputs something. So you input x values, and it will return us a value. And it is defined for all values of x, and this is the relationship. Find the values of x for which f is an increasing function. Do you understand that? What does an increasing function mean? Can you draw an increasing function? Most basic increasing function we have learned is a straight line going up this way. This is an increasing function. But besides a straight line, can I also increase this way? Yes, it is also increasing. Can I also increase this way? Yes. These are the three possibilities for increasing function. What do they all have in common? What makes them increasing? What makes this decreasing? What makes this decreasing? What makes this decreasing? So what is it about them? The gradient. Yes, the gradient. So what can you tell me about every single gradient on this line, or these lines? They are all positive. What about all these gradients over here? They are all negative. So here we understand, oh, increasing function means that gradient more than 0. Do you know what you have to do now? What do you have to do? What has gradient got to do with, I don't know, what are we supposed to do with the gradient? dy dx. Okay, differentiate this. So f prime x, I'm sure you can do that. And you set it to be greater than 0. Okay, without working through everything. This is power 3, right? After you differentiate, what power do you think you will get? After you differentiate power 3, what do you think you will get? Power 2, you'll get a quadratic, right? You will end up with a ax squared plus bx plus c greater than 0. You know how to solve this? Solving quadratic inequality, you have to factorize more than 0. You need to draw your graph. You need to select the relevant region. Done. Okay? So understanding the problem, coming up with your plan, solving it. So we have come up with the plan already. I am not going to waste time solving it because that's the easy part. Next question. The graph of y equals to log ax. Do you understand what y equals to log ax means? We can convert it to a form that we are more familiar with. A to the power of y equals to x. We are naturally more okay with powers than logarithms. But as long as you see that they are just directly related to each other by this conversion, you should be able to do some more questions already. Okay, passes through the points with the coordinates. Oh, I've got a full set of coordinates over here, x and y. Oh, this is only partial. This is only partial. Determine the value of constant a, b, and c. How to start? I don't know what I can do. It sounds very complicated. So break it into smaller problems. What can you do? Sub. Do you want to sub the first set or the second set or the third set? First set, right? Because I see, wow, 1, 2, 3 unknowns over here. If I substitute the first set in here, I'm only left with one unknown. Which unknown will you then be able to solve? You can find A. Okay, so we know that A can be found. Now once A is found, are you able to find the value of B? Using the same relationship, right? Y equals to, A power Y equals to X. We have already found A. In the second set of coordinates, I've got an X value. Put it in here. We've already got A. So I can find the Y value, which is the B value. Done. Next. We want to find C, which is an X value. You put in the Y value over here, and you can find X. That is the plan. Carry it out. Next, sketch the graph of Y equals to log AX. So this one, either you memorize or you start to plot some values. Okay, and you will see that it looks like this. It doesn't touch the y-axis. Then you must always show the intercept. You can figure out what this is. Question 3. Number of bacteria doubles every 3 hours. Do you understand what that means? If at the start there are 10 bacteria, okay, this is a ridiculously small number. At the start, time equals to 0, we've got 10 bacteria. What happens after 3 hours? When time equals to 3, how many bacteria? It doubles. So how many do we have? 20. What about when time equals to 6? How many? Now it becomes 40. We keep doubling this number. Oh, over here. We keep doubling it every 3 hours. So that's what it means. N naught, N with a 0 at the bottom, is the number of bacteria present at a particular time, and it's the number of bacteria present T hours later. Calculate the constant K. Do you know where to start? Don't know where to start? Do you understand the question? N naught is the number of bacteria present at a particular time, at a certain time, at the start. There is a reference timing. Time equals to 0. We've got the number of bacteria given by N. Okay, so this is number at start. This is number after T hours. Okay, so this is exponential. We expect the numbers to keep increasing. Calculate the value of the constant K. I think we kind of get the question already. But what can we do? Is there anything that we can substitute? This 0 over here mentioned that it is at the start. That tells us that time equals to 0. The number of bacteria equals to, is it equal to 0? When time equals to 0, can the number of bacteria be equal to 0? Let me write this. This is N, T equals to 0. So when I say N3, I mean N with a time equals to 3. Okay, so NT equals 0. What does that, how does that help us? When time equals to 0, this becomes 0. Right? Time is equal to 0. 0 times K, don't care. It will just give you 0. E to the power of 0 is just 1. Am I right? Then we have the number at the start will therefore be equal to N naught. So that's what it means when time equals to 0. When time equals to 0, N equals to N naught, E power K times 0. So N equals to N naught. Okay, so that's what it means. Now, what happens when, for example, time equals to 3? What then will we have? N equals to N naught, that is a constant, times E to the power of K times 3. Okay? So here we have two equations with so many unknowns. Wait, do we really have so many unknowns? The N and the N naught. This is N3. What can we do from here? Can we try dividing? These are some things that you have to try by yourself. Okay, try dividing. You see the N naught and the N naught? You see the N and the N3? Is there a relationship between N and N3? Yes or no? What is the relationship? Instead of writing N3, can I rewrite N3 as something else? Knowing that it doubles every 3 hours. 2N. N3 is actually rewritten as 2N. Right? It doubled. So how about we take this equation, equation 2 over equation number 1. If we were to do that, what do you think will happen? Will the n and n cancel? Yes. Oh, will the n naught and the n naught cancel? Yes. Oh, e power k 0 is just 1. It doesn't exist anymore. It's just multiplied by 1. What will we be left with? We have an unknown k. One equation, one unknown. I think you can solve it. Okay? So that is how we find the value of k. Next. Okay, this is always a question that I love. For part 1, ax squared plus 6x plus c is always negative. We really need to unpack this. What does this mean? It is always negative. What kind of expression is this? Ax squared plus 6x plus 6. What kind of expression is this? Quadratic. If it is a quadratic, then it's a parabola. If it is a parabola, it either opens up or opens down. No choice. So, it is always negative. Always negative means it always below x-axis. Which of this is possible? Or rather, which is impossible to always be below the x-axis? Which one is impossible? Opening up or opening down? A parabola opening up, can I say that this is always below the x-axis? No, because we know that it always extends this way. So this is impossible. The only possibility that we have left is this. So we are now going to try and describe this parabola. This is a parabola opening downwards. What can you tell me about the coefficient of x squared? What can you tell me about the coefficient of x squared? Less than 0. So here we have one of the requirements. A must be less than 0 for it to be a parabola opening downwards. But for a parabola opening downwards, it doesn't necessarily have to look like this. It could look like this. It could also look like this. These are all parabolas opening downwards. But for it to always be negative, which case is it going to be? Case number 1, 2, or 3? Or can it be a combination? We know that this is obviously wrong. This is obviously accepted. Is this accepted? Is this always negative? No, we've got one point over here. It is equal to 0. So this is also not counted. So what topic do you think they are testing over here? Roots. Roots of an equation. Discriminant. That comes in already. So are there any roots over here? No roots. No roots means discriminant less than 0. Okay? So we have b squared, which is 6 squared minus 4a times c less than 0. This is our second condition that we must fulfill. After you work all this out, you are able to give suggestions for values of a and of c. Okay, this one is more open for part 2. But this is the approach. Now, I'm going to change the question. Okay, I'm going to change the color to blue. Now it is always positive. Okay, can you tell me what are the conditions now? A must be? What would it look like? What will your parabola look like? Will it still look like this? It must open up and it must be above the x-axis, right? So what is the first condition? A is positive. What about the discriminant? What about the discriminant over here? What is the description? Are there any real roots? No real roots. If there are no real roots, what can you tell me about the discriminant? less than 0. Hey, look, whether it is the original question or in my question, whether it is always positive, always negative, we will find that discriminant always less than 0 because no real roots. Do not ever go away thinking that, hey, if it is always negative, then my discriminant should be less than 0. So if it is always positive, then my discriminant should be more than 0. There's no such thing. You have to understand why. The discriminant tells us the nature of roots. And why does the discriminant tell us the nature of roots? We always fall back to our basics. Ax squared plus bx plus c equals to 0. What does this mean? If I have a parabola, x given by y equals to ax squared plus bx plus c. This is my parabola, this is my x-axis, otherwise known as, this line is also known as y equals to 0. If I were to solve these two equations together, 1 and 2, I will end up with ax squared plus bx plus c equals to 0. Solving simultaneous equations is finding the intersection points. So I am trying to find these 2 points over here. I'm trying to find the 2x values by solving them simultaneously. If I were to solve this equation, we all know, the quadratic formula. X equals to minus b plus minus square root b squared minus 4ac over 2a. We end up with 2 answers, 2 possibilities. Okay, let me separate them. Minus b plus b squared minus 4ac over 2a. Okay, let's change this to a minus first. I put a smaller number on the left, or the other one, minus b plus square root b squared minus 4ac over 2a. These are our 2 values. One on the left, one on the right. Have you ever encountered keying quadratic formula into your calculator and then you get an error? You get an error, right? Sometimes. Then what do? You try pressing again. Did I really make a mistake? So if you had made a mistake, then you wouldn't get an error. But in the event that there's no solution, then which part of the quadratic formula causes your calculator to tell you no solution? When you try to square root a negative number, when you try to square root a negative number, it will give you an error. If it gives you an error, it is telling you that there is no solution. When there is no solution, graphically, means there are no intersection points. If there are no intersection points, then our graph looks like this. No intersection points. So over here, our quadratic formula will return us an error if b squared minus 4ac less than 0. Now if b squared minus 4ac is a positive value, then you will get 2 different values of x. Because it is minus b, subtract a number, divide by 2a. The other one is minus b plus the same number, divided by 2a. So you will get 2 different values over here. 2 real distinct roots. Now is there a case that we get a parabola that just touches the x-axis? Is it possible for this parabola to exist? Definitely. What this means is that there is only one solution. If there is one solution, which part of the quadratic equation causes these two to have the same value? When will they have the same answer? Only when b squared minus 4ac is equal to 0. Because you minus 0, you plus 0 is the same thing. Okay? So, this highlighted part tells us whether you have one solution over here, whether you have no solution, or whether you have 2 solutions. Next question. Sketch a parabola. Y squared equals to 4x. if it is changed to become y equals to 4 x squared, I'm sure you know how to do it. It's a parabola that looks like this. But now, the x and the y, they kind of switch place. So our parabola will now open to the right. We can plot this out for ourselves also. For every single x value, for every single, for every x value, we will have corresponding values for y. So next part, x minus 1 intersects the parabola at a and b. Intersection, understanding the problem, it is finding solutions to our simultaneous equation. So equation number 1, equation number 2, substitute. So we can get points A and points B. So A will be a set of coordinates, B will be a set of coordinates. Next part, the next part is 5 marks. Let's see what they want. Show that the midpoint of AB lies on the line. How to show a midpoint lies on this line? Are they saying that? Listen up. Is the question trying to tell us that this is the equation of AB? No. That's not what they're telling us. They are telling us that midpoint. Show that the midpoint lies on this line. My AB could look something like this. This is the midpoint. For example, it could look like this, and x plus y equals to 5. We can tell quickly it is a negative gradient. So they want us to show that this set of coordinates satisfies this equation. Meaning, if I have the midpoint of x1, y1, if I were to substitute it inside here, left hand side has to be equal to right hand side. That is how we prove that something lies on the line. So our job now is to find the midpoint of AB, which is also not difficult. It is the halfway point between the x values, add and divide by 2. It is the halfway point between the y values, add and divide by 2. For cosine square x minus 2 sine square x. Cosine square, sine square, immediately you must think of your trigo identities. Cosine square x plus sine square x equals to 1. Cosine 2x equals to 2 cosine square x minus 1. 1 minus 2 sine square x. You have to think about all these things. Express it in this form. Now they want it in cosine 2x. Quite clearly, this is going to be useful. I can rewrite my cosine square x in terms of cosine 2x. I can rewrite sine square x in terms of cosine 2x. By doing so, I can solve part 1. Change all your sine square, cosine square to cosine 2x. Done. State the greatest and the least values of fx. Now fx becomes a cosine 2x plus b. Greatest. Fx. When does it occur? Now b is going to be a constant. We're going to find b is a constant. No matter what, b is going to stay there. The variable is x. Different values of x will result in different values of 2x. Different values of 2x will result in different values of cosine 2x. Different cosine 2x will result in different a cosine 2x. So this x over here is the variable that is causing the fx value to change. If I want this to be as large as possible, b is not going to be a factor. A over here might be a factor. Depends on the sign of a. Okay, so if I want the greatest fx, I want the greatest a cosine 2x. The greatest cosine 2x is actually 1. The smallest cosine 2x is negative 1. Now if a is positive, I didn't work it out. If a greater than 0, and we want greatest fx. Okay, this is the condition. If a is greater than 0 and we want the greatest fx, what do we want cosine 2x to be? I want it as large as possible. A is a positive number. Let's say 10. Then what do you want cosine 2x to be? If you want fx to be the largest. 1, yeah, I want it to be 1. So that you get 10 times 1. That's the largest already. 10 times 1 plus whatever that b is. Now if a is less than 0, and I want the greatest fx, what do I want cosine x to be? Yeah, negative 1. Because negative 1 times a negative number gives you a positive number. So the positive number plus that constant b will be the greatest value of fx. So the least value, then you know what to do already. State the period and amplitude. Amplitude over here. Period will be 360 divided by 2. Sketching the graph. Do you understand the modulus? Modulus is not scary. Basically anything that is negative becomes positive, that's all. So sketching this graph means sketch y equals to 2x minus 4. And you just flip everything that is below the x-axis upwards. 2x minus 4 doesn't take you long to sketch it. It is a sloping arc, passes through negative 4. Done. So negative 4, put in the intercept. When x is equal to 2, y will be equal to 0. Now we're going to reflect this upwards. So if this is negative 4, this must be positive 4. We're going to remove the line at the bottom. This is now our y equals to modulus 2x minus 4. Now a line of gradient m passes through the point 0, negative 1. Negative 1 over here. So it has a constant gradient. It is a straight line. There are many possibilities that we can have. So straight line passing through negative 1 could be horizontal, could be positive slope, touching only at one point, could be positive slope, touching at no points, positive slope, cutting 1 point, 2 points, positive slope, cutting only 1 point, and so on and so forth. Just so we get positive, we get another straight line in blue. Now they tell us that m is equal to 3. Oh, a straight line with gradient m, and they give you the y-intercept. So this means y equals to 3x minus 1. This is the line. Find the coordinates of points of intersection of the line and the graph. Again, intersection, simultaneous. So equation number 1, equation number 2. Solve. Solving modulus, also not difficult. So 2x minus 4 equals to 3x minus 1. Solving modulus, pretend the modulus doesn't exist. That will be case number 1. Case number 2, remove the modulus but change all the sign. So case number 1, pretend it doesn't exist. 2x minus 4 equals to 3x minus 1. Solve, get your x value, and substitute it back in here to see if it makes sense. Case number 2, 2x minus 4 equals to, change all the sign on the right hand side. Or if you change on the left hand side, doesn't matter, it is the same thing. Get your x value, substitute, see whether they make sense or not. Done. Part 3. Determine the set of values of m for which the line intersects in 2 points. It has to intersect at 2 points. So earlier on we drew many different cases that are possible. For a line to intersect at 2 points, it cannot look like this, right? Because it's only intersecting at 1 point. Now what is this gradient over here? This gradient, the rise is 1 unit, the run is 2 unit, half. Okay, or you can use your y2 minus y1 over x2 minus x1. So this gradient is half. This is not acceptable because you only pass through 1 point. I want something that is more steep than this, because when it gets more steep, then it will pass through at 2 points, yes? I want it to be more steep. Okay, I know gradient has to be more than half. But can I have the gradient to always be more than half, and that's the answer? Would there be a certain gradient that causes that to only be one intersection point? When would that be? So let us increase the gradient again. Oh, I'm still intersecting at 2 points. Right, keep going. The only time that it doesn't intersect at 2 points is if they are parallel. So you only intersect at 1 point. So I cannot have this answer also. What is this gradient? This line has a gradient of 2. So if it is a parallel line, this also has a gradient of 2. I cannot have gradient half, I cannot have gradient 2. It must be something in between. So this is the answer. Anything more than gradient, anything equal to or greater than gradient 2, it is going to only intersect at 1 point. Right, so for tangent theta to cotangent theta equals to phi secant theta. Show that it can be expressed as this. Dealing with identities. We tell you to start from the easier or from the more complicated side. Can you tell whether one looks more complicated than the other? If you can't tell, then your choice to start from wherever you want. But remember that one of the approaches you can take is to change everything to sine and cosine. Can we actually do that? Tangent theta becomes sine theta over cosine theta. Cotangent, cosine theta over sine theta. Secant is 1 over cosine theta. This is, I've got fractions now. Adding and subtracting of fractions, I have to ensure that the denominators are the same. To make the denominator the same, this will become sine squared. Then this will be cosine theta, sine theta. This will become cosine squared. And this will become sine theta on top. So we now have generated the sine squared, which appears over here. Now depending on this coefficient, all these coefficients, they are going to affect your numerators also. By further rearranging, we will end up with this. Because all the denominators, you can multiply both sides, and all the denominators will be multiplied by 0. Okay, so go and try this. In part 2, they say hence. Hence means you have to search for the relationship between part 1 and part 2. 4 tangent 2x, 2 cotangent 2x, 5 secant 2x. You have to see, you have to realize that they are found here. Four tangent, plus 2 cotangent, plus 2 cotangent, equal to 5 secant, equal to 5 secant. What are they trying to get you to do? They are trying to get you to replace let theta equals to 2x. Then you can quote your previous result. Therefore, to solve this is as good as solving 2 sine squared 2x minus 5 sine 2x plus 2 equals to 0. They are trying to get you to solve this. This is quadratic. If you like, you can say let y equals to sine 2x. Then we get 2y squared minus 5y plus 2 equals to 0. I'm sure you can solve this. Get your basic angle and then all the steps for your trigo equation solving. Check your answers, check the range. So that's the plan, carry it out. So I skipped the question on proofs in plane geometry. Here we have a train traveling on a straight track passing through signal x with speed 30. 20 seconds later, passes through speed 10. Acceleration is given by a equals to kt minus 2. Acceleration is kt minus 2. The acceleration is dependent on the time. As time changes, acceleration changes. This is non-uniform. Non-uniform acceleration. We know that acceleration is related to velocity through our calculus. T is the time, t seconds after passing x. T seconds is time after passing x. So when it passes through x, the time is equal to 0. Time equals to 0. So here we have a relationship. When time equals to 0, velocity equals to 30. We can write it like this. V 0. Velocity when time equals to 0 equals to 30. In the same way, velocity when time equals to 20, it is 10. We also have acceleration. I don't know how to continue from here. So think about what you can do. There is a relationship, right? I differentiate velocity, I get acceleration. I integrate acceleration, I get velocity. Does it make sense to differentiate these two? No, they are just constants. You differentiate them, you get 0. Does it make sense to integrate this? If I integrate this, I should get velocity. Okay, let's see what we can do from here. V equals to integrate kt minus 2 dt with your brackets. Half k t squared minus 2t plus c. Wow, now my job, now it looks more complicated. I've got another c. But is it really more complicated? They are telling you that when time equals to 0, velocity is 30. What do you think the value of c is? 30. So 30 is supposed to be half k 0 squared minus 2, 0 plus c. Therefore, c equals to 30. Managed to get one unknown. Replace this with 30. So this one has served its purpose already. What about v20? When time equals to 20, velocity equals to 10. What shall we do with that? When time equals to 20, velocity is 10. There's only one thing we can do. Substitute them here. 10 half k 20 square minus 2, 20 plus 30. One equation, one unknown, solve for k. 5 marks. Find the distance. Okay, now that we have a complete expression for the velocity, how do we find the distance? It has to be integration. So the displacement is given by the integration of the velocity. So some things you need to take note. Did it make a turn? Because if it made a turn, our displacement only shows the distance relative to the starting point. So those are the things you need to find out also. Let velocity be equal to 0, find out whether it made a turn, then calculate total distance. Is there a possibility that it made a turn? This is the velocity. When it makes a turn, velocity equals 0. Definitely this could be equal to 0. So we need to check all those things. Now 11. Okay, so we have PQRS, open trough. It is symmetrical. These two angles are the same. These two distances are the same. This is a trapezium. Okay, you have to be able to tell that. Find the area. Area of a trapezium. What do you know? Area, half sum of parallel sides times perpendicular height. That's what we know. Sum of parallel sides. Can I actually find out from here? 30. I need PS. How do we find PS? If we draw perpendicular lines, to help us. Now this is 30. I've broken this problem of finding PS into 3 parts. The center part is the easy problem. I solved that first. Now I have 2 more problems. Can I find this distance? How? What do I need to use? This is a right angle triangle. I've got a hypotenuse. I've got angle theta over here. If this is theta, alternate angles, this is also theta. Hypotenuse, angle, I need adjacent. So Kevin rightly pointed out, cosine theta is adjacent over 20. So this adjacent that I'm looking for over here will be 20 cosine theta. And this is 30. By symmetry, this is also 20 cosine theta. I can do my first part, sum of parallel lines. Now I need perpendicular height. This is the perpendicular height. If you can tell me that this is 20 cosine theta, you have no problem telling me that this is 20 sine theta. So we're going to add them up, we're going to multiply them together. And let's see what we get. Area, half 30 plus 30 plus 2 times of 20 cosine theta. So this is the sum of the parallel sides multiplied by 20 sine theta. Continue to simplify, expand and simplify. Half and 20, this becomes 10, this disappears. I now have 60 plus 40 cosine theta multiplied by 10 sine theta. Continue to expand. I get 600 sine theta, very happy. Plus 400 cosine theta sine theta. Oh no, it's different. If you trust in your work, you have to realize that these two must be the same. And your job now is to make this the same as this. I've got cosine theta sine theta, but I've got 2 sine theta here. Can I change my cosine theta sine theta to become sine 2 theta? Then you have to remember, sine of 2 theta is actually 2 sine theta cosine theta. With this in mind, can I extract 2 sine theta cosine theta out from here? Sure, I can. This becomes 600 sine theta plus 200 2 cosine theta sine theta. And now my sine 2 theta has appeared with a coefficient of 200. Now they are the same. Now theta can vary. As theta changes, the volume is going to change. Can you imagine if theta becomes really, really small? If theta becomes really, really small, then our straw is going to look like this. Can it fill a lot of water? Cannot. When theta is really, really small, the volume is really, really small. The area is very small. Can you imagine if theta is really, really great, very, very big? How big? Maybe this big. So by symmetry, the other side also same. Theta. Is the volume big or small? Again, it is very small. So we can imagine as theta changes from small to very big, the area and therefore the volume changes from small to big, then to small. So this is a question where we need to use our differentiation. dA over d theta. You get an expression, set it to be equal to 0. We want to find a turning point. At which point does it change? Once it is equal to 0, find the value of theta. That will be when we have either a maximum or minimum area. After that, we still need to check d2a over d theta squared. Substitute in this value. Whether it is bigger or smaller depends on the sign of d2a over d theta squared. So that you can do by yourself also. Coming to the last question. Equation. a point moves along a curve in a way x coordinate of p increases. Okay, this part I need everybody to look up. All look up. X coordinate of p increases at a constant rate of 0.02 units per second. This means that dx over dt equals to 0.02. We need this. The next part is even more crucial. The y coordinate is decreasing at 0.36 units per second. This means that dy over dt 0.36. Do you all agree? Or is this wrong? Right or wrong? Wrong. This is wrong. Because they say it is decreasing, we have to put a negative sign. Okay, when something is decreasing, we expect the gradient to be negative. So these are the keys to this question. So find the x coordinate. I've got a dx dt, I've got a dy dt, and I've got a y equals to in terms of x. Definitely I need dy dx. And I need to link these three up. So with practice, we realize that with try and error after practicing, we get dy dt is dy dx times dx dt. This is a constant. This is a constant. These are numbers. Here we have a variable x, meaning after you do a substitution, you have one equation, one unknown. That's what they want you to find, x coordinate. For part 2, in part 2 they are telling us that the area for A equals to area for B. This one is direct, it's straightforward. So integrate y with respect to x from 1 to a. This will be equal to integrate from a to 4 y dx. Okay, by doing so, you will only have one unknown, one equation, one unknown, a, solved. So I've shown you the plan for every question in this paper. Your job is to execute the plan. Think about all this. You notice that in less than 1 hour, in approximately 1 hour, we came up with a plan for everything already. Then the doing part, you have to write fast. Don't take your time to think. Don't take your time to write. Okay?